Hello, in 1.4 we're going to be talking about rays and angles. So a ray is a part of a line with one endpoint that extends indefinitely in one direction. So the difference between a ray and a line is that a ray extends only in one direction indefinitely, whereas a line extends in both directions indefinitely. So a ray has one endpoint and it extends from there. So we can label this with two letters, WT, with an arrow on one side. We could also label this ray as XT. The second ray that I drew begins at S and extends out through X. So we're going to call that SX. So ray SX. So note that it always starts with an endpoint. An angle, you guys have seen angles before, but we're going to give it a formal definition. So it is formed by two non-collinear rays or sides that meet at a common point or vertex. So we can extend a ray from C through A and then also from C through B. So our two sides or rays are ray CA and ray CB. And those are our sides. And then our vertex is the end point for both of those rays. So that would be point C. Make sure you're pausing if you need time to rewind and listen. So an angle divides a plane into three distinct parts. Points C, B, and D lie on the angle. So you can see that the angle is made by the two sides and the vertex. Point A lies on the exterior of the angle because it is outside of the angle. And point E lies inside the angle because if we extend our rays out, it would be in the middle of the angle. So note exterior and interior of an angle. So name a point on the exterior of angle DEB. So we have angle DEB. Can anyone name a point for me? We have point G on the exterior, and we have point F on the exterior. Note how they are outside of the angle. So now name all the angles that have B as a vertex. So if we call it just angle B, people won't know what I'm talking about. But we have angle 7. We have angle 5. Angle 6. And we also have angle GBA. And note that for angle 7, angle 5, and angle 6, there are multiple ways that you can label those. So angle 5 is also angle GBE or angle GBF. So just note that there are multiple ways of notation. Name the sides of angle 5. So we have angle 5 here. And note the vertex is B. So we're going to start with B and extend out through G for our first side. So I'm going to write ray BG. And then I'm also again going to start at B and extend out through E. So I'm going to call it ray BE. You could also call ray BE ray BF because it does go through point F here as well. Now I want another name for angle 7. I could call it angle ABD with my 3 points. with my vertex in the middle. I could also go the other way, angle DBA, but notice that my vertex, my B, has to always be in the middle. Now we're going to talk about types of angles. So many of you have seen this first one. It would be called a right angle because it forms a 90-degree measure. So you've worked with right triangles using the Pythagorean theorem and SOHCAHTOA, stuff like that. So that would be a right angle. And this angle is smaller on the inside than the 90 degree. It looks like you're folding it in. That is called acute angle. So an acute angle measures less than 90 degrees. I don't know, think about little puppies are cute, so it's smaller, so it's acute. I don't know, maybe that helps or not. An obtuse angle is folding it out and making it bigger. So an obtuse angle measures greater than 90 degrees. So there, think of leaning a chair back, an obtuse angle. And then here, we have a straight line, so it is called a straight angle. And a straight angle measures 180 degrees. We're going to classify these angles as acute, right, or obtuse. So angle SYT, is that acute, right, or obtuse? That would be acute because it is less than 90 degrees. You can see that it looks like it's folded in. Now angle SYX is obtuse because it looks like it's folded out. It's bigger than 90 degrees. Can anyone name a right angle in here? That would be angle VYX because it is marked with the little square in the corner. That is how they describe or notate a right angle in a figure. Now we're going to talk about an angle bisector. An angle bisector is a ray that splits an angle into two congruent angles. So we have angle WXZ, and then we have ray XY that splits the angle. But then we just learned about congruency, and so the bisector means that angle WXY is congruent to angle YXZ. So note the two angles are the same. So if ray KN bisects angle JKL, so we have JKL and ray KN bisects that angle. So if measure of angle JKN, so that's this one right here, the JKN, measures 8x minus 13, and the measure of NKL, so NKL is 6x plus 11. How do we solve for x? We just said previously that if we have an angle bisector, the two angles are congruent. So that means their measures are the same. So we can set up that 6x plus 11 equals 8x minus 13. Solving for x, we move our 13 over, we get 24. We move our 6x over by subtracting it, we get 2x. We divide by 2, and we get 12 equals x. But the question was saying find measure of angle JKN. So that was again, JKN was our 8x minus 13. So we want to plug our x in. So we have 8x minus 13, but we know that our x is 12, so we take 8 times 12 minus 13. We get 96 minus 13 to give us 83 degrees for the measure of angle JKN. Again, pause and rewind this part if you didn't follow, or come see me if you have more questions. So moving on to section 1.5 in angle relationships. First, we're going to talk about adjacent angles. Adjacent angles are two angles that are adjacent, two angles are adjacent if and only if they share a common side and have no interior points in common. So, adjacent angles are going to look like so. So we have Q, P, P, and N. So we have that angle P, Q, P, and angle T, Q, N are adjacent. So you've learned about adjacent using SOHCAHTOA before, so that means next to. So we have our one endpoint is Q, and then they share Q side QT, so they have a common side, and they have no interior points in common, so they're next to each other. You can put them up next to each other. A linear pair, two angles form a linear pair if and only if they are adjacent angles and their non-common sides form a straight line. So they have to be adjacent, but they also have to form a straight line. So if we have a straight line, let's say we have M, N, and V, and then we want adjacent angles out of this. So that would be drawing an array. So we have our two adjacent angles, M and W and V. But notice that they make a straight line, so that means that they are a linear pair. So linear means line, 180 degrees. So angle M and W plus angle W and V equals 180 degrees. And then also note that they are adjacent as well. So vertical angles, you're going to think two angles are vertical angles if only if they are adjacent, non-adjacent angles formed by two intersecting lines. So non-adjacent, think, when you hear vertical angles, think of an X. So angles 2 and 4 are vertical angles. Angles 1 and 3 are vertical angles. So angle 1 and angle 3, and then angle 2 and angle 4. And also note that vertical angles are congruent. So angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, and we'll use that concept or theory further on. So just to recap, adjacent angles share a side, a linear pair forms a straight line, and notice a linear pair also forms a T, either on its side or upside down or rotated some way or another. And then vertical angles, you're looking for that X. Complementary angles. Two angles are complementary if and only if the sum of their measure is 90 degrees. Then one angle is the complement of the other. So when you hear complementary, think corner because it makes a 90-degree angle. And note that they don't have to be next to each other. So we'll look at some examples in the next few problems and also in the homework. Supplementary angles are two angles that the sum of their measure is 180 degrees, and one angle is the supplement of the other. So think supplementary, think straight. So they make a straight angle. So they add to 180. All right, so now looking at these, if we're given an angle of 25, what is the complement? Remember, it has to add to be 90 degrees. So the complement would be 65 degrees. The supplement, they have to add to be 180 degrees. So the supplement would be 155 degrees. Continuing on, 87 plus 3 is 90, and 87 plus 93 is 180. The complement of 134, it does not have one because you can't add anything to 134 to get 90 degrees. You can subtract something, but here we're thinking about adding angles. The supplement of 134 is 46 degrees. The complement of 8 degrees is 82 degrees. And the supplement of 8 degrees is 172 degrees. And the complement of 90 is 0 degrees because you're already at 90. And the supplement is 90 degrees. So on that one, think about two right angles adding up to be a straight angle or 180 degrees. Here we see the x, so immediately we think vertical angles. So name a pair of vertical angles. We have angle WXV or and angle YXZ. There is another one. We could have angle WXY and angle VXZ. So note that they are opposite sides of the x. So how many pairs of vertical angles are in this diagram did we just say? We just named them both. So there are 2. And now name 2 angles that form a linear pair. There are quite a few in here. Think about all of your straight lines. So we have angle ZXV and angle VXW. So note that the linear pair again has to form a straight line and be adjacent. So we also have something like angle YXZ and angle ZXV. There should be 2 or 3 more, I believe, 2 that you can name. So if I didn't list the one that you had in mind, doesn't necessarily mean it's wrong. So now we're going to solve for x and the angles of a supplement. So the degree measure of an angle is 3 times the measure of its supplement. So when you think supplement, think straight. Okay, so we want to draw a straight angle. And then we have 2 angles. So we have a ray extending out from in between those 2. Now, we have the degree of an angle is 3 times the measure of its supplement. So we have 3 times its supplement. So we're going to have an angle x, and then we have 3 times the measure. Now, these have to add to be 180, so you have x plus 3x equals 180. So you get 4x equals 180 by combining like terms, divided by 4, and you're going to get that x equals 45 degrees. So one of our angles is 45 degrees, and that makes our other angle 3 times x, but we know x is 45, so 3 times 45. So we know that angle is 135 degrees. And note again, 135 plus 45 is 180. Now we're looking at complementary angles. So the degree measure of one of two complementary angles is 6 more than twice the other angle. So we have a 90-degree angle, think corner. And we have two angles. We have one angle we're going to call x, and the other angle is 6 more than twice that angle. So 6 more than twice that angle. And note that they have to add up to 90 degrees. So adding the two together, you get 6 plus 2x plus x equals 90. Combining my like terms, I get 6 plus 3x equals 90. Subtracting my 6 over, I get 3x equals 84. Divide by 3, I find that x equals 28 degrees. So my first angle here is 28. Now, I could plug back in to my equation, my 6 plus 2x, or I could also ask myself, this angle plus this angle have to add up to 90 degrees, so I'm going to take 90 minus 28 to give me 62 degrees for my complement. Now perpendicular, you guys have talked about perpendicular before, but we're going to define it. So two lines are perpendicular if and only if the lines form right angles. So the symbol for a perpendicular line is an upside down T. And we have two lines that form 90-degree angles. So note that each one of these angles in here is 90 degrees. So perpendicular lines form 4 right angles. And perpendicular lines intersect to form 4 sets of adjacent angles. So note, adjacent angles, we have 1, 2, 3, and then 4. So again, if you want to see those, go ahead and count again or rewind to watch. But think about moving in a clockwise motion to get each adjacent angle. So now we're going to find x and y so that lines PR and line SQ are perpendicular. So we're going to start by solving for y. So we want PR and SQ to be perpendicular. That means that this angle right here has to be a right angle adding up to 90 degrees. So we know that that angle has to be 90 degrees, but we also know that it is equal to 4y minus 2. So what does y have to be? If we add our 2 over, we get 92 equals 4y. Divide by 4, we get that y equals 23. So if y equals 23, this angle is a right angle. Now, we also want to solve for x. So we know that not only is angle PTQ a right angle, but also STR is a right angle. So this has to be 90 degrees. So we know that that is also 2x plus 5x plus 6. Just like we were adding segments the other day, we can add the angles, and that has to equal 90. So combining like terms, I get 7x plus 6 equals 90. Subtract my 6, I get 7x equals 84. And then I get that x equals 12 by dividing by 7. So again, if you didn't follow this, please come in and ask for help or rewind and watch again. But good luck on the practice.